So while I agree the title of 332 is a little dorky, fraction busters, the purpose really is to get rid of unfavorable numbers when you're solving an equation. And so these are sort of like little cheats almost for making an equation easier to work with. We're going to continue with different types of complex equations. We had rewriting, we had looking inside, and we had undoing. And we sort of add fraction busters to that list as like our fourth strategy because it is very helpful in making an equation more manageable. Sean was trying to solve for x in the equation 0.4 times x minus 2 equals 3.4 minus 0.2x. He said to his teammate, "Oh, decimals, I wish that we only had equations with whole numbers." Suddenly, April blurted out, "Wait, Sean, I think there's another way. Can't you first rewrite this equation so it has no decimals? Then it will be faster and easier to solve." So what's April talking about? She wants to rewrite it so there are no decimals left. And one way to do that is to look at all the decimals that are in the equation, 0.4, 3.4, 0.2. They all have a decimal to the tenths place. And so one thing that we can do is to multiply the entire equation by 10. So we're going to multiply both sides by 10. Now, that does come off as being a little easier than it actually is because there's a very common mistake. So we're going to multiply everything on the left, minus 2, and everything on the right by 10. And the reason we're multiplying by 10 is because it will move our decimal point over to the right one place. And the problem is this first set where there's a 0.4 times and then there's an x minus 2 in parentheses. The 10 does not get distributed to everything. You've got a 10 times 0.4 and then it's being multiplied. So you're really only multiplying that number that's out in front by the 10, whereas in the second half, you're multiplying both parts by the 10. So 10 times 0.4 is just going to be 4. Notice nothing inside the parentheses changes. And then on the other, 3.4 when it moves over one place is 34 minus, and 0.2 when it moves over becomes 2x. So definitely more manageable and easier to work with. If we then wanted to solve it, from this point, I would distribute the 4 to both sides. Since 34 and 2 aren't divisible by 4, I wouldn't use that strategy. I would rewrite 4 times x minus, and 4 times 2 is 8 equals 34 take away 2x. I now have an equation where I can start solving by doing things to both sides. So 4x minus 8. So I'm going to choose to add 8 on the left, add 8 on the right. So I've got 4x equals 34 plus 8 is 42 minus 2x. I need to get all my x's on the same side. So now I'm going to add 2x on the right and add 2x on the left. 6x equals 42, and this is looking wonderful because 6 and 42 very compatible. Division on the left to get rid of the times 6, so divide by 6 on the left and the right, and we get x equals 7. The reason this was so much nicer is because I wasn't constantly adding things with decimals, multiplying things with decimals, dividing things with decimals. So rewriting it gave us an equivalent equation that was much easier to solve. Two equations are equivalent if all their solutions are the same. There are several ways to change one equation into a different equation or equivalent equation. Common ways include adding or subtracting the same number from both sides, which we've been doing for a couple years now, multiplying or dividing both sides by the same non-zero number, which we've been doing for a while now. But usually we take numbers that are in the equation and do things to both sides with them. Now we're taking a number that doesn't already exist and saying, let's apply this number to both sides the same so that we can make the equation easier to work with. And even though it's decimals, it's still under the heading fraction busters because you will come to find out that we use this method for fractions as well. So this first one, I'm going to look tenths, 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 hundredths. So because one of our decimals is in the hundredths place, we're actually going to multiply the left side by 100 and the right side by 100. And the reason for that is we want to make sure we move the decimal point far enough. So if I move this one 2 places, it's negative 750x squared plus, move the decimal point 2 places, 480x minus, and move the decimal point 2 places is 30 equals, same thing on the right, multiplying by 100, so 250x squared plus This is the one that had the two places, so it's 1002 minus, and a 10 multiplied by 100, going to be 1000x squared. So now we've gotten rid of all the decimals, lots of numbers ending in 0, which makes them also pretty friendly as well. I would start by moving around on the right side, because the right side happens to have some like terms that can be combined. 250x squared minus 100x squared is negative 750x squared. And those of you that can sort of see the future, notice there's a negative 750x squared over here. So they actually cancel each other out because there's the same one on the left as there is on the right, separated only by addition and subtraction. So I've got 480x minus 30 equals, and then I've got the 1002 on the right. I'm going to add 30 to both sides. 480x equals 1032. And then divide both sides by 480, just following the regular order of operations backward. X equals 2.15. Now, I'm not surprised by this. I'm not surprised by the fact that the answer is a decimal because the original equation had decimals. I'm also not surprised that it goes into the hundredths place because we did have a number in the hundredths place. Maybe even a thousandths place wouldn't have surprised me that much. But just think about the fact that the original equation did have decimals, so it should not be unnerving that the solution has decimals. This one is actually a little bit backward from the ones we've done so far, the first two examples, because this one has too many zeros. And so we're going to say, all right, 2,000's got 3 zeros, 5,000's got 3 zeros, 18,000's got 3 zeros. I'm going to divide the left side by a 1 with 3 zeros, and I'm going to divide the right side by a 1 with 3 zeros to minimize the extra that we don't need. Again, we're going to not divide by the thing that's in the parentheses. We're only dividing by the 2,000, which is 2. And the plus 5,000 divided by 1,000 is going to go down to just a plus 5, and then equals 18. The reason for that is if we distributed the 2,000 times the x and the 2,000 times the minus 24, then we would have to divide both of them by the 1,000. But since it hasn't been distributed yet, we can do it just the once. And at this point, you can start with distributing the 2, or you can do that slightly faster method. Get rid of this 5 because it's not involved in the parentheses. And I would have 13. And now instead of distributing the 2, we said that we could use the undoing method and divide the left side by 2, divide the right side by 2. X minus 24 equals 6.5, 6.5. You also could go with fractions. The original problem didn't have fractions or decimals. Most kids prefer decimals, so that's all right. And then add 24 to both sides for an x equals 30.5. Not a particularly unfriendly number, so I'm not thrown off too much by the fact that there's a decimal because it's a very familiar decimal, a very easy decimal to work with, a half. All right, so then we're going to flip this over and look at the back side. Solving by undoing. We actually kind of just did this. I did the solving by undoing on 3,122. We added the 5 to both sides and then divided both sides instead of distributing. Fraction busters. So here's the part where we look at busting the fractions. This equation looks like it's going to be a lot of work with adding fractions. They don't have a common denominator, but there is another way to tackle equations with fractions, and they're going to walk us through this. Multiply each term by 6. What happened? So if I multiply everything on the left by 6 and I multiply everything on the right by 6, the 6 over 6 in the first term just leaves us with x. The 5 times 6 leaves us with 30 over 8, and I'm just going to leave that alone for just a second, equals, and the 4 times 6 gives us 24. And now you're like, so Miss Fraser, we still have a fraction. It didn't do what you said. No, but if I want to get rid of that 8, I can do this step again. The first time it got rid of the 6. If this time we multiply both sides by 8, we might be able to get rid of that 8 in the denominator. 8 times x is 8x minus 8 times 30 over 8. This time the 8s would cancel, right? 30 over 8 times an 8 over 1. You would only have minus 30. Equals, and the 24 times 8 is 192. So we multiplied by 6, followed up by multiplying by 8, and it busted. It got rid of both the denominators. So I just have this really nice, friendly, easy equation to work with. I can add 30 to both sides. 8x equals 222. I can divide both sides by 8, and I get x equals 27.75. You can go with the fraction. You can go with the mixed number. Again, I'm not terribly thrown off by this because 0.75 is 3/4. Very easy, manageable, terminating decimal. So what do we take from this? By multiplying by one of the denominators and then multiplying by the other denominator, we were able to eliminate them both and have a very manageable number. But if anyone noticed here that multiplying by 6 and multiplying by 8 is the same as multiplying by 48, there was actually a smaller number we could have multiplied by instead of 6 and 8. What is the least common multiple of 6 and 8? Because it's not 48. There's a smaller one. It was 24. We actually could have multiplied in one step the whole equation by 24, and it would have made this faster, and it would have made it more efficient. We would have more efficiently gotten down to a usable equation that had smaller numbers. So let's look at that in the next one. We have a 3 in the denominator, and we have some 2's in the denominator. Least common multiple of 3 and 2 is 6. So I'm going to multiply the whole left side by 6, and I'm going to multiply the whole right side by 6. Now, some of you are going to be able to see this very easily, and other people are going to need to write it out. I don't care which people you are, as long as you know which people you are. So 6 over 1 times 5x over 3, right? That's the first multiplying by 6. These simplify. 2 times 5x is 10x, plus the 6 over 1 times 15 over 2. Again, I can simplify. 6 divided by 2 is 3. 2 divided by 2 is 1. And 3 times 15 is 45 equals. And then when I multiply the right side by 6, 5 times 3 is 15. So by choosing the least common multiple of all the denominators, which is a 6, I can get rid of all the denominators and have a nice, easy equation. Subtract 45 on both sides. 10x equals negative 30, and divide by the 10, x equals negative 3. Not a problem to solve as long as you can get rid of the fractions at the beginning. So this one has a variable in the denominator, and that is going to be part of what we multiply by. And some people just can't see this one very quickly, and they go, I'm not going to try to do it all at once. I'm going to do it in steps. And, in the beginning, that's not a bad thing to do. So you might want to start by getting rid of that x. So you might want to multiply everything on the left by x and everything on the right by x. On the first one, the x's would cancel and you'd have a 5, right? X times a divide by x, you'd only have the 5 in the numerator left. Second one, minus x times 2 would be 2x. And then over here in the answer, you could just put negative 11/8 x. There's nothing wrong with that. I multiplied all 3 parts by x. What did I get? You still have a denominator of 8. So now I might go through and multiply everything by 8. So on the left, I'm going to have 40 minus 16x. And on the right, the 8 in the denominator with the 8 I'm multiplying by cancel, and I get negative 11x. And I solve the rest of that, no problem. What could I have multiplied by in the very first step? The least common multiple was 8x. So I could have multiplied the whole left side by 8x and the whole right side by 8x. But some people don't see it that way, and it's okay to do it in 2 steps. So I'm going to subtract. Oh, I don't want to subtract 40 because there's only x's on both sides. So I'm going to add the 16x. Add the 16x. If I had subtracted the 40, it wouldn't have gotten me anywhere. It wouldn't have made my problem any closer to being solved. And I will have a positive 5x and divide both sides by 5. 8 equals x, with the better way to write your answer, always with the variable on the left side, x equals 8. So this time we want to look and see if we can do it all in one step. I would say that I have a denominator of 2x and another one that's just 2. So they both have a 2 in common, and I also need to get rid of the x. So I'm going to multiply the left side by 2x. I'm going to multiply everything on the right side by 2x. So the first one, 7 over 2x times 2x, they cancel, and you just have the 7 remaining. The second one, 3 over 2, multiplied by the 2x. The 2's cancel, but you still have 3 times x, or 3x. And 3 1/4 times 2 is 6 1/2. And because I multiplied by x, it's 6 1/2x. Could you have multiplied by x the first time and then multiplied by 2 the second time? Sure. This one, because the denominators were so similar, we could do it all in one step pretty easily. I'm going to subtract 3x from both sides because I noticed there were x's on both sides. So 3.5, x on the right is remaining, and divide by 3.5, and I get 2 equals x, with the better answer with the variable on the left, x equals 2. Are there any inputs, any values of x that are not allowed in these equations? The only problem that you would have is if you had a 0 in the denominator. So in these equations, we've got a couple places where there's an x in the denominator. So that would be our only issue. X cannot be 0. That would make it undefined. All right. So no zeros in the denominator. That would be our only issue. If a value of x is not allowed as an input, it is also not allowed as a solution. Why not? Well, if it's not allowed as an input, it also can't be the solution because basically what you're doing is you're finding the input when you solve it. That would also result in undefined variables. So we would say correct, also undefined values. So that would be the same issue. X cannot be 0. The input cannot be 0 means the same thing. So your solution cannot be 0 because basically you're solving for possible inputs. The last thing that we want to look at are these questions that are supposed to be group questions. So I'm just going to walk you through a few potential options. You can always try other ones and ask me about them in class as well if you want to try your hand at mixing it up a little. Reverse the process of solving by trying to make them more complicated. So on the first one, I might choose something like multiplying by 1,000. And I might multiply everything on both sides by 1,000 and get 4,000x minus 2,000 equals 6,000x. And because I multiplied everything by 1,000, it's still going to have the same solution. I just reversed the problem and made it more complex. The second one, you might put some denominators underneath. So you might do something like 5 over 8 minus 3x over 8 equals negative 7 over 8. And the fraction buster would say, oh, just multiply everything on the left by 8, multiply everything on the right by 8, and you'd get back to your original equation. You could also turn things into decimals. So you could move your decimal point the same amount of places. You could do something like a 0.2x plus a 0.1 equals a 0.5. And if you've ever done a standardized test that had a question that looked like this, all of a sudden you're sort of doing that smack yourself in the forehead like, oh, this would have been so much easier if I knew about fraction busters. Truth. The last thing you could do is change up the way things look. So maybe you're going to put everything, say, over 3. So maybe I'm going to put like x over 3 minus 6 over 3 equals 3 over 3 plus 2x over 3. But maybe I want to make things just a little bit more tricky. So maybe this one, instead of being x over 3, maybe I write 1/3 x. And then instead of 6 over 3, I put 2. And instead of 3 over 3, I put 1. And then plus 2/3 x. So there's a lot of ways to mess around with it and make it look more complicated than it actually is. And what you'll notice is that oftentimes your teachers will do this to equations to make them a little bit more complex. And once you know the fraction busters trick, you can sort of combat our tricks for making equations more tricky. You don't have to do parts B and C because those are things that you would do with your group. And since we're not in groups, I am confirming that these are all equivalent to the original equations. And hopefully I see you in class with some questions. Have a great night.